Let's say for whatever reason, budget cuts, a very optimistic plumbing engineer, or a bureaucratic mix-up of catastrophic proportions, someone decided that all of Niagara Falls should be redirected through a single drinking straw. Not a metaphorical one, a literal plastic 7mm wide straw from a fast food soda cup. Bold choice. First things first. Why anyone would do this is already a good question. Maybe someone looked at the massive thundering wall of water, the pride of Canada and the United States, and thought, you know what this needs? Portion control. Let's move past the why and go straight to the what now. When we try to imagine Niagara Falls going through a straw, we might think, well, sure, it'll be a tight squeeze, but the water will go faster, right? That's partly true, but also very misleading, because fluids, it turns out, don't like being rushed, and Niagara Falls is nothing if not a very, very pushy guest. On average, about 100,000 cubic feet of water per second pour over Niagara Falls. That's roughly 2.8 million liters every second, which is enough to fill an Olympic-sized swimming pool in under half a second. And you're telling all that to go through a straw the size of a pinky finger. Here's what would happen. At first, nothing. The water would pile up behind the straw, awkwardly forming a puddle the size of upstate New York. A straw can only allow so much water through at once, and if you're expecting it to be anything close to 100,000 cubic feet per second, you're in for disappointment and probably a flood. Now, let's say you try to help things along. You add pressure. You build a dam and force the entire Niagara River to push against that straw with all its might. What happens then? Physics says bad things. There are limits to how fast water can flow through a narrow opening, no matter how much pressure you apply. It's called choked flow, and it's like trying to push rush hour traffic through a mouse hole. The more you push, the more resistance you get, until the system just can't keep up. Eventually, if the pressure is high enough, something even weirder happens. The water begins to boil, not because it's hot, but because the pressure drops so dramatically inside the straw, thanks Bernoulli's principle, that the water can no longer hold itself together. It starts forming vapor bubbles, a phenomenon called cavitation. Cavitation is what happens when water essentially loses its mind. These vapor bubbles form and then collapse with tiny explosions that erode metal, destroy pipes, and in some cases, make engineers cry. So now your superpressurized water is trying to boil itself into a frothy mess inside the straw, which, incidentally, is beginning to melt, or shatter, or both. Because even ignoring cavitation, the force being exerted on the straw is astronomical. Still, let's say, through magic, bad ideas, and industrial-grade optimism, you find a straw strong enough to survive. Let's even imagine that the water does get through. Now we calculate how fast it would have to move. A standard drinking straw has an internal diameter of around 7 millimeters. That gives us a cross-sectional area of about 0.385 square centimeters, or 0.000000385 square meters. Take your 2.8 million liters per second, which is 2,800 cubic meters per second, and divide it by the area of the straw, and you get a velocity of, wait for it, 72 million meters per second, which is more than 1/5 the speed of light. A few things would go wrong here. First, water isn't supposed to go anywhere near the speed of light. At that speed, it would stop being water. The molecules would shear apart. You'd get plasma, radiation, and probably the wrath of several physics textbooks. Also, the energy required to accelerate that much mass to relativistic speeds would exceed the output of every power plant on Earth combined. You wouldn't just have fast water. You'd have a beam of deadly high-energy particles, like the world's most impractical particle accelerator. This water beam would carry so much energy, it would incinerate the straw, the dam, the town, and most of the eastern seaboard. The surrounding area would glow with the kind of brightness normally reserved for the sun, or Judgment Day. Oh, and fun side note, the power output of this straw, if somehow achieved, would exceed the total solar energy that hits the Earth every second. So, congratulations. You've turned Niagara Falls into a tiny, unstable star, all thanks to your 3-cent plastic straw. Within moments, the atmosphere would heat up, the oceans would boil away, tectonic plates would sizzle, and the Earth, unable to handle the sheer force of your stupid plumbing idea, would likely crumble under its own poorly thought-out ambition. So, to answer the question, no. You can't funnel Niagara Falls through a straw, not because the laws of engineering say so, because the laws of physics, fluid dynamics, and common sense collectively rise up and scream, please don't. But if you do try it, just be sure to get permission from the International Niagara Committee, and maybe say goodbye to the planet.
Don't think you'll be able to click on the next video before time run out. 3, 2, 1.